In today's video on financial maths, we're going to be looking at present value. Present value is what the investment is worth now, but it's important to bear in mind that now can be a fairly flexible concept in this regard. And I need to decide what I mean by now in the questions that I complete. So our example is that Meg wants to invest a sum of money for 10 years at an AER of 3%. How much must she invest to have a final amount of 20,000? So let's first of all refer to the log tables and select the appropriate formula. So the formula we'll use in this case is the present value formula, P equals F over 1 plus I to the power of T. And let's make a note of the pieces of information that we know to fill into the formula. The final value is 20,000. The interest rate is 3%, and don't forget we need to write that as a decimal. So that's 0.03, and the time is 10 years. And now we can substitute those values into the formula. So we'll have 20,000 over 1 plus 0.03 to the power of 10. On typing this into the calculator, we can see that our answer is 14,881.8783. And of course, we're dealing with money, so let's round it off to 14,881.88. So this value is our present value. And what does that actually mean? Well, it means that if Meg invests this amount now at 3%, then in 10 years' time, its value will be 20,000. So now here's a question for you. I've invested a sum of money at an AER of 2%. In 5 years, it'll be worth €10,000. What's its present value? Pause the video here while you work this out. So I'll first of all note my formula and I'll substitute in my values. I'll go to my calculator and here's my solution. So the answer is 9,057.31. And again, what does this mean? Well, it means that if I invest this amount now at 2%, then in 5 years it'll be worth €10,000. Here's a second example. Today is Sinead's 40th birthday. She is due to receive a lump sum of 150,000 on her 65th birthday. If there's a discount rate of 3%, calculate the present value of the lump sum. Okay, so again, we know how much it's going to amount to in the future, and we know the interest rate and time involved. Just notice in this case that the phrase discount rate is being used. Discount rate is just another way of saying interest rate, and it tends to be used if we are given a final future amount and we're working back towards a present amount. So let's make a note of our formula and let's substitute in the values. So the final value of the lump sum is 150,000. The interest rate is 3%. Again, don't forget to write that as a decimal. And the lump sum is due to arrive 25 years in the future. So T is 25. And when we type this into the calculator, we get 71,640.84. So again, what does this mean, this present value? Well, it means that if we were to take this amount right now and invest it for 25 years at 3%, it would amount to 150,000 at the end of that term. So here's a question for you. I want a lump sum of 50,000 on my retirement in 15 years. If the discount rate is 2.5%, calculate the present value of this lump sum. Pause the video, do the question, and then play and see if you're correct. So I'll first of all make a note of the formula, and then I'll substitute my values in. And my solution is 34,523.28. This is the present value. So again, what that means is that if I was to put this amount of money into an investment now for 15 years at 2.5%, it would amount to 50,000 at the end of that term. So here's a third example now. This is a little bit different. Tom is due to pay Sarah 5,000 in 5 years' time to clear a debt. He offers to pay her 2,000 next year and 2,500 the year after instead. If the annual discount rate is 5%, determine if she should accept his offer or not. So it's quite difficult on the face of it to compare these values, 5,000, 2,000 and 2,500, because they're all being paid at different times. So what I'd like to do is have them be comparable by calculating the present value of each of them. So we have our formula, and we'll first of all apply it to the 5,000. If you know where this is going, feel free to pause the video here and complete the question yourself and then play and see if you're correct at the end. So I'm taking that 5,000 figure first. So to work out the present value of the 5,000, I'm going to put in T is equal to 5 to bring it right back to now. And that comes out as 3,917.63. So that means that if I had that amount of money, the 3,917.63, and I stuck it in the bank now for 5 years at 5%, it would come out as 5,000. Okay, so next I'm going to look at the 2,000 that he's offering to pay her next year. So in this case, I've got 2,000 over 1 plus 0.05. I haven't put the power in yet. What should the power be? Well, he's offering to pay her the 2,000 in 1 year's time. So to bring it back to the present moment, I should put a power in of 1 because that's 1 year. So that's 1904.76 as a present value. So if I was to put 1904.76 into the bank for 1 year at 5%, it would come out as 2,000 at the end of that year. And the present value of that 2,267.57 is the amount that I would need to invest now for 2 years at 5% to get 2,500. So the question is, should Sarah accept Tom's offer or not? At first glance, we might say no, because 2,000 and 2,500 is less than the 5,000 that he owes her. But when I look at the present values instead, I can see that the two amounts that Tom is offering to pay Sarah back actually have a present value of 4,172.33, which is greater than the present value of the 5,000, which comes to 3,117.63. So she should accept his offer because it's more financially advantageous to her. And if she was to take that 4,172.33 at the moment now and put it into the bank for 5 years at 5%, she would come out with more than the 5,000 she was originally meant to receive from Tom in 5 years' time. So here's a question for you now. So your question is that Mike owes Sean money and is due to pay 3,000 next year and 4,000 the year after in order to clear the debt. Sean suggests that Mike can pay 2,000 next year, 2,000 the following year and 3,000 the year after that instead. Should Mike accept the offer? Pause the video here, complete the question and then check and see if you're correct. So again, in this question, on the face of it, it looks like Mike is paying Sean €7,000 either way. However, if we take each amount and bring it back to its present value, we can then more accurately compare and see whether Mike is getting a better deal with the first option or with the second option. So let's start by making a note of our formula. So let's examine option 1. So we'll start with the 3,000. This 3,000 is due to be paid in 1 year's time. You might notice I've forgotten to put in the discount rate. The rate's 6%. So my calculation here is 3,000 over 1 plus 0.06 to the power of 1 because that 3,000 was to be paid in 1 year's time. And it has a present value of 2,830.19. In option 1, he'd also have to repay 4,000 the year after. Let's find its present value. So we've filled in our formula first of all. And the present value in this case is 3,559.99. So I'll add these two together. And I can see that option 1 has an overall present value of 6,390.18. So on we go to option 2. Sean's suggestion is that Mike should pay 2,000 next year, so that's this 2,000 here. Filling that into the formula, we get a present value of 1,886.79. In option 2, 2,000 is also due the following year, which is a present value of 1,779.99. And the following year requires a repayment of 3,000. And this final one has a present value of €2,518.86. Overall, the present value for option 2 is 6,185.64. So on a purely financial basis, this second option is more favourable to Mike because he has less to repay when all the information is taken into account. The present value for option 2 is less than the present value for option 1, so Mike should accept the offer.